Good morning, I'm Ronnie Rama, and I'll be talking to you about domes. I think it's always exciting. I think this whole idea of the trip is an exciting event for you and for me to think that you're going to be going to all these great places and have these great experiences. One of the things I wanted to tell you is that I do think of architecture as a facilitator. I'm trying to formulate my own definition of architecture, and one of the definitions that I'm coming up to over and over in my head is this idea that architecture facilitates the human experience, or it tries to imitate sometimes the human aspirations. Whether that human experience is the need for shelter, whether it is the human experience the need for protection, whether it is the human experience can be defined self-actualization. In many instances, architecture provides the framework for it. And I think as you travel, as you visit all these different places, you might be able to feel that self-actualization in the same way that you can feel the protection, or you can feel different emotions that in part architecture provides, in the same way that going to a mountaintop or sitting under a tree or sleeping under the stars can provide those experiences. That's why I want to talk to you at the beginning about celestial vault. And this idea that humans have always been fascinated by the experience of the sky, this experience of the open sky, especially at night when you can just contemplate an open, dark night sky with all its beauty. And I came across, as I was looking at this idea of the celestial vault, I came across this project, 1992. James Terrell is the designer. La Haye, or sometimes The Haye, is a city in the Netherlands, and this is right outside the city. And as you know, the Netherlands is a very flat land mass. The idea of the land mass is kind of relative because it's really swamps. In this idea of the water coming in and the people reclaiming the land. And one of the things that happens when you are in this open place, especially if there's a city close by, is you really cannot really appreciate the night sky. So James Terrell wanted to provide this in a very busy and well-lit city. So he created this ellipse that is about 120 feet long in one of the axes, 150 feet long in another one of the axes. He raises a wall, basically a rammed earth wall that is 15 feet high, and he creates this plinth in the center. So people can go to that plinth, especially at night. I'm not sure how safe this place is. It's right by a restaurant, so I guess people go to the restaurant, and after that they go and contemplate the night sky. And basically it is where you can just lay down on this plinth and not be encumbered by all the lights coming from the city of La Haye, and basically contemplate. I think I said 1992. I think the project started in 92, it was finished in 96. And it is one of those experiences that as human beings, I think most of us want to be able to have. And we are going to be talking about domes, and we're going to be talking about these buildings, but I think in all their expressions, domes kind of reflect this idea of us thinking about the celestial dome that surrounds us all the time. So as in architecture, we kind of try to recreate that experience. So there's all those different types of domes. They're associated with how the construction happens. I really don't expect for you to remember all those terms, although some of those are pretty cool, like the geodesic dome, because it has to do with the idea of the triangle and the repetition of the triangle all along the circumference of the sphere. But basically, a dome is a hollow shell, and it's used in architecture basically as a covering, as a protection. Okay? So that is the definition. And now I want to talk to you about some of the different places that you will have a chance to visit and why they're so significant. And I really hope that you can grasp, and I think this is the hardest thing. When you go to those places, when you think, when those places were built, when those places were created, and to think the technology and the daring attitude of those that created it, because they really surpass sometimes the human understanding today. How were they able to figure out that they could build that, and then much more going about through the whole process of creating these wonderful spaces. To me, it's kind of interesting to know that one of the earliest human structures that were found was created from dinosaur bones and tusks, in mammoth actually, bones and tusks. And they created basically a shelter out of these elements. And the shape itself is that of a dome. And it was found in the Ukraine and is dated 19,000 years before the Common Era. Basically, when you talk about a dome, the understanding is you have certain forces that go from the cusp of the dome, and they transmit weight uniformly around those meridional lines. And then they also have to address these lateral forces, which are called hoop forces. And an engineer can explain that to you much better than I can. This is a basic earth oven or a brick oven. And what I like about it is it basically shows you how the different rings of a brick oven reflect the forces of the dome. So you notice that as it starts going up, it also starts tilting inwards. It's a great way of cooking pizza and bread. And it has been done for ages. I watched my father one time build one of these. And it was really fascinating to think about the whole process. Here's a man with a third grade education that could really figure out how to create this shape, structurally sound and very effective for cooking. So here we go, the Pantheon. The last time I was there, very hot day in Rome, and all of a sudden you get to enter this free space that is 2,000 years old. Very hot summer in Rome. You're tired of walking around and the whole experience, and you come to this marble floor. And all I wanted to do was to lay down on the floor. And that's what I did. Until a guard approached me and reminded me in Italian that no, you cannot lay down on the floor. It doesn't matter how hot you are. It doesn't matter that you're holding a Uruguayan passport, by the way. It does not allow you to do this. This structure, just consider, it is the 1st century. And they want to create a temple to the gods, celebrating the gods. And what better structure than a celestial vault, something that basically encompass all the Roman deities, and all surrounded by niches on the wall that celebrate a lot of those deities. What I love about this structure is that one is the size. You know, when you think a diameter of 142 feet, and it's interesting because we're going to see other domes like we're going to see Il Duomo in Florence, and we're going to see the St. Peter's Dome, and we're even going to consider St. Paul's in London, and they still cannot reach the numbers that the Romans were able to reach with a construction method that is, you have to understand, the shell of that dome, it starts very thick, and because it starts so thick, they start using the covering to lighten up the load, and once they get to the oculos, which is that ring, the 16-foot diameter hole, that when you're laying down on the floor looking up, and right before the guard comes, you look up and you think, that thin shell at the edge is so thin, and they're trying to make it so hollow so it will not have weight when it approaches the oculos, that they start putting glass bottles inside the mix. So the glass bottles are just to fill in space. And it allows for that cement, that Roman cement, which is different than reinforced concrete, to really be light in that edge. So they can reach that ring, and then they can remove all the scaffolding and the whole dome hold in place. 142 feet in diameter. So you have certain words to remember. One of them is the oculos, which is the opening for the dome. The other one, the idea of covering, and you see it there with those rosettes and those basically squares that are just designed to allow for the structure to be thinner and lighter, but also allow you to see the forces. You have the meridional forces going right here, and on this side, the hoop forces along the rings of the dome. I want to show you quickly a video. Oh, maybe it will not play.
Yes, it escaped.
Escape.
No.
And that play.
And you can do it again. No, play the second thing. No, it's not working.
Oh, there.
Yeah. And do the full screen thing on the right, on the bottom. Yeah.
And why is it not volume? Sorry.
We forgot to check the sound. I forgot.
Let me just pause it. Sorry. Technical difficulty. I can always skip and just continue
You
talking.
guys know the sound?
It's okay. I can continue talking, and they can
Okay.
they see it on the
Yeah.
on the presentation?
Yeah. Yes. Yeah. Mm-hmm.
Okay. All right. So just know that on the video you can access this quick National Geographic video. There's going to be another quick National Geographic video about Santa Maria del Fiore in Florence, which I think that they're very informative. But going back to the building of this particular structure, consider they don't use steel. They don't even use iron in the construction. But they are able to create this very shallow dome that basically they calculate the size of it so a sphere, a perfect sphere, can be placed in the center. They're able to, the Roman engineers are able to calculate that and construct it to where even today all the measurements fit for a perfect sphere to be placed in the center of this grandiose building, and consider 142 inches in diameter. So then, we're talking 1st century AD, Anno Domini, and then we move all the way to this 1300s. There have been other domes built, like for example in the city of Istanbul, Hagia Sophia. But even when you consider Hagia Sophia in Istanbul, in the 5th century, it's still, the dome itself is smaller than the one in the Pantheon in Rome. They still cannot achieve that size. By the 13th century, Arnolfo del Cambio designs Santa Maria del Fiore, a huge undertaking, and he dies before he can even figure out how to cover the altar area. So he leaves an octagonal drum about the size of the diameter of the Pantheon, and he basically says somebody else will figure it out, which is great as a designer. Just pass on the problem to somebody else. Okay? I'm designing this beautiful building. Now somebody else will figure out. It takes years for somebody to figure out. And finally, we get to the height of the Renaissance, the 1400s. And we find Brunelleschi appearing. Brunelleschi, a very smart sculptor who really is always in an antagonistic relationship with all the people around him. The whole idea of Ghiberti and the competition for the doors of the baptistry in Florence, and you're going to be sitting right there in front of Santa Maria del Fiore. You're going to be looking at the baptistry and those beautiful bronze doors. Just remember the fight between Brunelleschi and Ghiberti over those doors, because everybody wanted the commission because of all the money associated with that. Basically, artists at war. And what you find is that Brunelleschi loses the door competition. And that's the best thing that can happen for Santa Maria del Fiore. Because Brunelleschi losing that competition to Ghiberti and getting opened out of shape because he loses that competition, it means that he leaves Florence together with his friend Donatello. And they go and they have pizza. No, I'm sorry. They go all the way to Rome with Donatello. And he says, I'm going to come back to Florence and bring something back to Florence greater than the doors to that baptistry. So he goes to the Pantheon in Rome. And together with Donatello, they measure the Pantheon. And he says, ooh, mamma mia, the size of the drum at Santa Maria del Fiore is similar to the size of the drum to the Pantheon. So he takes all those measurements and he goes back to Florence. And he says, I can create the dome for it. One of the first things that he does is he has to demonstrate that he can do it. So there's another building under construction, which is San Lorenzo, the Church of San Lorenzo, right by the Medici Palace. So he goes there and he basically creates a dome for that building. And the dome for San Lorenzo is basically Brunelleschi telling the people of Florence, I can do a dome. It's a tiny dome, but this is an example that I can do a dome. He even builds a model for it. A wooden model for it that you can walk in. And again, he's trying to demonstrate, I can do it, give me the commission. Well, off and on for the next 30 years, they're going to give him the commission to build the dome, but it's always going to be under the supervision of Ghiberti, who doesn't know anything about domes. So the whole building of the dome is a really interesting process. There's a book called Brunelleschi's Dome that kind of goes over the accounts of the whole building and all the process. Brunelleschi has to create all kinds, invent basically a crane to bring out the materials to the top of the dome, even a special crane so they can bring up wine for the workers, a whole system for latrines in a high level so the workers don't have to go all the way to the bottom and go down the street to a bar so to use the facilities, so they can do it all upstairs and then the workers don't lose time. So really, you have to consider how amazing the whole building of the dome is. And climbing to the top of the dome, which I think should be mandatory for all students that can. There's not an elevator. 463 steps. Just for you to get an idea, just to go from the ground floor of the Don Morris building to the third floor and visit me in my office, that's 44 steps. If you do that 10 times, you go up 10 times, you go down 10 times, it's still not quite what it would be like for you to climb and go up and down to the top of El Duomo. But it's certainly worth it. So you get to this middle level of the climb, and you come and you... I'm not sure if you admire or are horrified by the paintings by Vasari of... this is his interpretation of Dante Alighieri's The Divine Comedy and his idea of hell, purgatory, and heaven. But all that depiction is there, and then you get to actually climb within the dome. And the dome itself, you see here, this is Giotto's bell tower. Right here is the baptistry, and right here you have Brunelleschi's dome. So you go from this ring right here, and then you get to walk inside the dome. It's a double shell. It's just a magnificent experience, and you get all the way up to the top of the dome. Great view of the whole city of Florence. It's really worth the experience. Notice I'm not going to mention much about St. Peter's, although St. Peter's is another great experience. Instead of 463 steps, going up to the top of the dome in St. Peter's is 551 steps. The only secret that is there and the only shortcut that you have is you can take an elevator to the base of the drum, and you save 320 steps by doing that. It is more expensive to buy a ticket to go to the top of Il Duomo, Santa Maria del Fiore in Florence, which is about 15 euros. It is a bit cheaper, like 13 euros, to go up to St. Peter's. So consider doing it, and always take pictures, post pictures, send pictures. And then lastly, I'm going back to the beginning of your trip when you're in the city of London for you to consider St. Paul's, which is 528 steps. And you can go up as well. And the cost is about 16 pounds. Remember the change of currency. One is euros, and in England you still have pounds. And I wanted to end by showing you this comparative graph of the different buildings. So here is the Pantheon. It's a rather short building. But the interesting thing is that in diameter is very close to Santa Maria del Fiore. It is close, but about 6 feet larger. Pantheon is larger than St. Peter's. And look in comparison, St. Paul's in London. The difference between these buildings. This is a single shell, double shell for Santa Maria del Fiore, double shell for Michelangelo's dome on St. Peter's. Sir Christopher Wren's, 3 shells. 3 shells, and weighing, coming in at 65 tons. I mean, it is one heavy building. Are there any questions? Yes.
Should I be more impressed with height or diameter when it comes to a dome? You know what I mean? Like, I love this image. This is really useful. But I can never remember which of these I'm supposed to be most impressed with.
I am personally most impressed by this one. when I think that it's withstood the test of time for 2,000 years.
If I'm remembering correctly, the width of the walls at the base of the Pantheon are 20 feet. So the thickness of the walls when the dome hits the edge is a 20-foot thick wall to support that dome.
Well, by the way, the walls at St. Paul's are 16 feet. And that's one of the things that he was really having trouble. It's extremely heavy in comparison to what the Romans were able to create in the first century. To me, to think that they were able to figure that out and accomplish this space with a building that allows rainwater to come in regularly. Yeah.
Is it harder to make a tall dome or a broad dome?
It's harder to do a broad dome.
Okay.
Yes.
Why do you make a dome with 3 layers?
Because first he wanted to create the sense of the sphere on the inside, but he couldn't achieve the necessary height for it. So one dome holds the next one, holds the next one. It's like Sir Christopher Wren was a mathematician and he still could not figure out how to do what the Romans did.
When they built the book that he mentioned, Brunelleschi's Dome, it's a short book, but it's really beautifully written. It's funny and interesting, has all kinds of great anecdotes and stories about Brunelleschi. Brunelleschi did lots of practical jokes that are hilarious and crazy,
He was a paranoid man.
yeah, but the most common theory on how the Pantheon held its dome at that point was magic, right? Nobody understood how the dome stood up, and so they all thought it was just, well, it's magic. That's how it stays up.
Yeah. Thank you very much. I really hope you enjoy the trip and try to take full advantage of all these experiences. They're truly life-changing.